Hey guys, what's up? I know the weather's a little bit downer today. This is on, what day is it today? Wednesday? I think it's Wednesday. It's kind of weird how it's hard to determine what days it is. Anyway, so the weather's a little bit rainy today, but you know what? It's still not too bad. So I'm going to sit outside and do some stuff today. So you're getting a lesson from outside. Anyway, this one is going to be a little bit shorter. So we're going to do some radical operations, but we're going to talk about solving equations with them. So it's going to be a little bit more fun, a little bit more in depth, but hopefully the video should be short. So enjoy, we'll get rolling. Radical equations. All right, this one is, it's going to be a little bit different than just operating with radicals because there's a special little thing in here called principal square root that we're going to make sure we talk about. So, but let's talk about a process of how we're going to solve these radical equations, and we'll kind of discuss that principal square root. Okay, so there's going to be a four-step process. The first step we want to do is we want to isolate the radical symbol. Okay, that's the first thing that we want to do is get that thing by itself. That just means moving everything that is around it to the other side of the equation. The second thing we're going to do is we're going to end up squaring both sides because then that takes away our radical there. Then we're going to solve it just like we would a normal equation, and then we're going to need to check it in the original equation. Okay, so all these steps will make sense here as we go through this. So let's start with a really basic one. 3 plus root m equals 13. Okay, now, yeah, so let's work through this. The first one is isolate the radical. So we're going to take that 3. We want to get rid of this and move it. So we're going to subtract 3 from both sides. We get root m equals 10. Then we want to square both sides. Notice we're not finding the square root of m. We are squaring. We're trying to undo that. Okay, so we get our answer here of 100. Okay, so if we plug that back in, that's where this check the original. By the way, this was the solving section here. Okay, now the checking in the original equation is we're just going to throw that back in there and see what we get here. Okay. So we notice that right here, we've got 3 plus the root of 100 equals 13. So the root of 100 is 10. Hold up. Did I just say that the square root of 100 is just 10? What about the negative? I mean, Mr. Reinhardt's always said that there should be a negative and a positive whenever you find a square root. That's weird. So 3 plus 10 equals 13. Okay? 13 plus 13 equals 13. We're good. Okay, so... second question here is going to be root 4m plus 1, and then plus 5 equals 0. Notice that this 4m plus 1 is all in there, so it's the root of the quantity of 4m plus 1. Okay, so let's isolate that square root. Notice the only thing that, the radical there, notice the only thing that we need to get rid of is going to be this one, because this is inside it, so this is part of it. So we just need to subtract our 5 from both sides. We end up with root 4m plus 1 equals negative 5, and then we square both sides, and we end up getting rid of the radical there, get 25 over here, subtract our 1 from both sides, divide by 4, and then we get 6. Okay, so we have solved it. That was all of this. Now we just need to check our original solution, so we plug that back in. Original equation, I mean. So 4 times 6 plus 1, we're just going to leave that in there. That's 25. Square root of 25 is 5. Okay, he just did it again. What is this whole idea of not including a negative? We better get this figured out. Okay, so what did I mean by principal square root? What the heck? Why, Mr. Reinhardt, didn't you use the negative version of that square root? But if I do the negative, then it does work. What happened there? Let's talk about this idea of principal square root. So if we look at a problem that's really basic, similar to what we've been working with in the other video, we would say something like the square root of m is going to be equal to 4. Okay, so what does this mean here? Well, the root of m, whatever m is, the root of that must be equal to 4. You're probably already realizing the answer is 16. Okay, so let's figure out how we solve that. Let's go do that really quickly here. We're going to square both sides. Okay, that's how we solve that because we want to undo the radical. So we're going to square both sides. And then what we find is that our answer over here, m, is going to be equal to 16. And that's it. That is done. Okay, the square root, the radical symbol, was already there. We wanted to find the root of m, whatever that was. Okay, notice that it's not a negative number. Could I put negative 16 inside that square root? No, I can't. That's not going to work. Okay, so the only version of this is going to be the principal square root, the positive version. Okay, it is different than when we use when we have a different equation. So let's say something like this. Let's say x squared is going to be equal to 25. Okay, so let's say that. So if x squared is equal to 25, let's try and solve that. Well, what we would do is we would do the square root. Okay, we'd do the square root of x squared and the square root of 25. And then we would end up solving this out. The square root of x squared is going to be x, and then the square root of 25 is where we find that plus or minus 5. And let's see if that's actually true. Okay, well, if I take negative 5 and I square it, do I get 25? Yes, I do. If I take positive 5 and I square it, do I get 25? Yes, I do. So in this case, both the negative and the positive work. And it's because we were applying the square root to operate on the 25. Over in the first one, we weren't applying the square root to operate on the m. We already needed to have the root of m. Okay, and so it's a different scenario there. Essentially, we're taught this idea of principal square root can get a little bit confusing, but understand that we are only talking about the positive because the root was already there. We're not introducing it to try and solve for the variable or try and solve for the answer. We needed the positive version only, the principal square root, because that's the only one that would work. Okay, so now that I've made that perfectly crystal clear, let's get back to the video and finish this one up. 5 plus 5 is 10, and 10 is not equal to 0. Okay, so there we go. This one is going to be a no solution. This is why we check our original equation. Notice up here, these two were equal, so therefore it works. Okay, but down here, notice these two are not equal, so it does not work. Okay, so that's why we are doing this last step of checking our original equation, because we need to see if it actually works. Okay, the next one, radical equations for number 3 here. We got root y plus 2 equals y minus 4. Okay, we need to, first step is isolate the radical. Well, the cool thing is the radical's already isolated. Notice that there's nothing else over here. Okay, so the second step is going to be to square both sides. Okay, this side becomes super easy because that just cancels out. Yes, the root of y over 2 or y plus 2 squared, that cancels out, so we're just going to get y plus 2 over here. But on the right side, it's a little bit more tricky. Okay, the right side, we're going to get this. This is the FOIL method, right? First, outer, inner, last. We're going to have y minus 4 times y minus 4. Okay, that looks like this over here. Okay, so y minus 4 times y minus 4, y squared. We've got negative 4y and negative 4y, and then we've got negative 4 times negative 4 is 16, so we end up with this right here. Okay, so that's how we got that. Go ahead and don't forget, pause the video if that's too quick for you. If I'm moving too quick, just pause the video and go back to it. Okay, now what we're going to do is we're actually going to we're going to solve this by a quadratic. Okay, this is solving. In the solving step, we have two variables. Do you see that? Let me go back one step here. We have two different terms. We have a y and we have a y squared. Okay, that means we need to use our quadratic formula here. We have a quadratic. Let's just get it simplified. So we're going to move our 2. So we're going to subtract 2 from both sides. That 2 comes over here. I don't know why I wrote it there. Sorry about that. That's going to be 16 minus 2. And then we need to move our y over there. Okay, and so then we're going to end up with 0 is equal to y squared minus 9, because this is negative 8 minus y, so that's negative 9y plus 14. Okay, so this is a quadratic. So let's start using the quadratic formula to get this solved. If you can factor it, go for it. If you want to do that, that's fine. Whatever methods we use for quadratic solving, you could use. You just need to choose the one that you want to do. We're going to do quadratic formula here. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Go ahead and sing that song in your head if you want to. I might even put a link in the pop-up here. So here we go. Negative b is going to be opposite of 9, so therefore it's going to be positive 9. And then b squared is negative 9 squared minus 4 times a times c. So 4 times the a term, which is 1, and the c term, which is 14. Okay? So this here is going to be 81 on the inside. Negative 4 times 1 times 14 becomes negative 56. So 81 minus 56 is 25. So we got 9 plus or minus the square root of 25. So it's 9 plus or minus 5 all over 2. And again, I know that I went through that quick, but you got a pause button, so don't forget to use that. Okay? Just go back a couple steps, hit pause, rewind it here, listen to the beautiful sounds of Mr. Reinhardt over and over again. Ha ha ha. Okay, so we got 9 plus 5 is going to be 14 over 2, which is 2, or which is 7. And then we got 9 minus 5, which is 4. So that's 4 over 2, which is 2. So we have two answers here, okay? We need to figure out which one's going to work, okay? Because we got an original equation up here. This is our original equation minus that, remember, that was the steps to help solve it. Okay, so let's plug this back into our original equation. Again, that was the whole point, or that was one of those steps, that last step there. So replace the y with 2 and replace the y with 7. So we're going to start with 2. So this one becomes 2 plus 2 inside the root, and then 2 minus 4 on the other side. So the square root of 4 is principal square root of 4 is going to be 2. 2 is not equal to negative 2. Okay, let's try this one. 7 plus 2 is 9. Root, principal square root of 9 is 3. So 7 minus 4 is 3. So this one ends up being true. So which one works here? Well, it's going to be the 7. Okay, it's not going to be the 2. Okay, now I know I went through that quickly. I know that you'll probably have some more questions. Feel free to hop on the video chat for that. And make sure you watch this video over again and do the best you can, okay? So enjoy.